Welcome to this webinar. My name is Beate Scheibel. I'm Area Manager of Area 3, Process-Based Manufacturing Orchestration.
And my name is Jürgen Mangler. I'm a senior scientist at the Technical University of Munich, and today we will talk about manufacturing orchestration engines.
Okay.
So if you like this webinar, there is other webinars we have produced. And if you check out our social media, I'm sure you will find them.
Okay, then let's start. Can you tell me what is a manufacturing orchestration engine?
Yes, I can. I'll try to be as concise as possible. So I think a good way of introducing them is to dive a little bit into the history. So on the shop floor, you typically have machines that interact with each other. And also sometimes humans interact with the machines because the machines need input. Yeah? This is typically referred to as a cyber-physical systems. And of course, all of these machines, they are run by software. Most moderns are run by software. Yeah? And when these machines work together, typically one machine tells the other what to do. So traditionally, robots, because they were the most modern machines on the shop floor, they had it was their task to, for example, tell a lathe to open the door or to start the turning process. And then when the door was open, the robot was going in and putting in raw material or taking something out. Yeah? So in this case, the robot basically was holding the logic how these two machines were working together. Yeah? So we have now these two machine case, and of course there exist more complicated cases, yeah, where many machines work together. For example, if the parts that have been produced have to be transported somewhere else, there is maybe some transport system, an autonomous one, or some line, who knows. And all of these things have to work together. Yeah? So many small pieces of software exist which are realized, yeah, by probably independent companies, or they're realized in-house, whatever, but they're typically small pieces of software which are written once, never touched again, and which somehow work together. Yeah? And then new things come and everybody is wondering how the old stuff works, and nobody wants to touch the old stuff. And the complexity is always rising because people are working around issues. Yeah? So the next idea was, yeah, there is some problems in this approach, as already was pointed out by me in the explanation. So the idea was that we can address some of these problems. And one of the concepts how to address this is a service bus. In the IT, typically they are called enterprise service buses. And the idea is that these service buses handle all the messaging and all the interactions between all the participating machines and humans and pieces of software. Yeah? So they are basically like some data flow routing mechanism. Yeah? But they also have some drawbacks, and there exist some pretty amazing ones, yeah, which are really hardcore, like Kafka, which can do all kinds of stuff, or much simpler ones in the IoT area, which and MQTT, which many know. Yeah, it's just a mechanism of like everybody participating in messages, but nonetheless all the participating parts still have to listen to the message flow, and or maybe they're directly addressed, and they have to take these messages, and the entities or the pieces of software or the machine that sends these messages has to know whom to address. So the logic, how everything works together, is still part of the individual functionality. So we solved like the communication problem, we simplified the communication, but we have not simplified the configuration of individual pieces, and we have not simplified this decentralized logic problem where nobody in big systems, nobody know exactly how the pieces work together. Yeah? So this brings us to these manufacturing orchestrations and engines, which go one step further. Yeah? Mm-hmm. So the idea here is to take this logic, which is distributed over all these particular machines and services, and centralize them. So the idea is that the logic which is in the individual machines, or the logic which is in individual pieces of software which have been created by whoever, the shop floor is always a heterogeneous place, that these become much simpler. Yeah? That we use only like basic functionality, like for a lathe, for example, like load a program, start a program, close the door, like very high level, simple interfaces, but no knowledge about the produced parts, and no knowledge of, not any semantic or domain knowledge. Yeah? And that so that all of these individual pieces become very simple and easy to deploy. And we have one centralized logic. Yeah? So we extract all the orchestration logic code out of these individual pieces and centralize them.
And where exactly does this logic go? Where do you centralize it? It would be a bad idea if we just like moved like pieces of logic, which are basically pieces of code, like to some central place. Then we would just have like reordered stuff. So the idea here is that this code is moved into a different notation. So typically, this code, which interfaces with the machine, is written by computer scientists. And you also have domain experts which know individual machines, but also you have domain experts which know how these machines should interact in order to create the product. Yeah? So you have, on the one hand, the domain experts, which are probably not computer scientists, and then you have the computer scientists which write the code. Yeah? And they can't exist without each other. Yeah? So the idea here is that we do away with all this code business and the computer scientists. The computer scientists are still needed like to interface to write low-level code, but at this higher level, where it's just about the interaction between machines, we want to have something that non-computer scientists can do, that the domain experts can do by themselves to further simplify the process and speed up the process. And also, like IT guys are not easy to come by, so this should be an advantage for companies that use the system. So the idea here is that we move this logic to a graphical notation. And in our case, we use the business process modeling notation, which is a little bit older, comes from office automation, but in our experience also very well suited for the shop floor. Yeah? And the idea here is that you have simple graphical models. These models are, of course, programs, yeah, but because it's hard to break them, they are not programming code, and because it's easy to change and move them around. And the idea is also that you can't make any programming errors. You can make semantical errors or logical errors that like a machine is doing the wrong thing, but you can't like have any syntactical errors that the program doesn't run because of computer science reasons. Yeah? So because of this property, domain experts can easily describe the logic themselves. That is the idea.
So that's low code.
Exactly, yeah. There exist many buzzwords in this area. So low code or no code, which is probably, no code is probably a little bit over the top. Most don't believe it when you hear it, yeah. But low code is the idea, in fact, yeah. And thank God we are not telling how low the code is, because of course a little bit of like thinking in logical terms is still needed, and that's the basic of programming as well. But in our experience, we were doing projects with multiple companies and even people with no computer science background at all were very happy that they could do and change something themselves, and things were moving. Yeah?
Okay, can you tell me more about which stakeholders are involved with manufacturing orchestration engines?
So there are basically three types of stakeholders which work with manufacturing orchestration engines. You have, on the one hand, you have the orchestration designers. They are typically the domain experts which know how these machines work together and which pieces of data are necessary for a machine to do the right thing, basically the NC program or whatever. Yeah? So they are basically building or modeling the program, yeah, and giving the calls to the machine or the orchestrations to the machine do something, the right parameters so that it can do its things. And they also like model that the potential return values from the machine, that they are stored locally and utilized in further calls to other machines. Yeah? For example, when I measure something at a certain that something is a certain thickness, maybe this is an important parameter for the robot so that the robot can grip it correctly. So these are these process designers. They know what's going on and how things should work together. Do not mistake that the programmers are still there. They created the interfaces for the machines. We are now just at a level where we no longer need them because we have generic interfaces and we can just tell how these work together. Yeah? So the second group of stakeholders are the orchestration participants. Yeah? So they basically know nothing about what's going on the shop floor, or it's possible that they know not. Maybe they know it, but it's possible that they know nothing. But they are required to provide input to the machines, because like not always everything is fully automated. Yeah? Sometimes like you need humans to like do some maintenance or to put in some new tools or to put in like some grease into the machine basically, or some coolant. Yeah? So these participants, they do not know the process model, but they get instructions by the orchestration engine. Yeah? During the process, I need you at this machine to do this and that. Yeah? So the orchestration engine is basically telling the humans when they are needed in the orchestration. Yeah? And the third group of stakeholders is the data analyst. While the manufacturing orchestration engine is running, lots of data is produced, because all this data, as we were talking about before, is flowing through the orchestration engine. We know the state of machines, we know the values of sensors, and all this data runs through the orchestration engine between the very separated machines. Machines no longer talk to each other, they just talk to the orchestration engine. So all the information that they gather and collect go through the orchestration engine. And so the orchestration engine is basically the perfect place for collecting and gathering data. Yeah? And this data gathering and data collection leads to very good and high-level logs, which can analyzed by data analysts, or which can even lead to runtime visualization of what's going on. And this visualization, of course, has to be created by data scientists or data analysts. And so the third stakeholder that is involved in this manufacturing orchestration engine is probably data analysts. So these work together. So the data analysts tell basically what information they need, which probably leads to additional sensors and small changes in the orchestration models. And also the whole orchestration can be optimized so that workers like have less work, or that it's easier for them, and that they get clear instructions. Yeah? So these are the stakeholders. So this was the first part of our webinar. If you liked it, you can maybe tune in to the next part. We will talk about which functions and which components are involved in such a manufacturing orchestration engines, and we'll also tell you probably more about some more technical issues.
Okay, thank you very much, Jürgen. This is part of our webinar series about manufacturing orchestration engines. If you enjoyed it, stay tuned for the next part on our social media.